Okay, here we go. So let's see here. We have the brain stretch, and we got some answers there, some good answers. We're talking about acids. So we got people here saying that the crowd says that vinegar, orange juice, and lemons are acidic. That is correct. Yes, give yourselves a round of applause for that. Acids taste sour. Yeah, just taste the lemon. You'll know how an acid tastes. They typically do taste very, very, very sour. Let's see here. I just read your message, Martin. That's cool. Yeah, show how amazing you guys are. They corrode metals. Remember, you don't want to keep acid in a metal container, so you don't have canned lemon juice. That would be a terrible disaster. It tastes horrible. They do increase the hydrogen ions in solution. That's really the key thing from a official science chemistry standpoint. And they do turn litmus paper red. We saw that yesterday in the video that we watched. So good job, guys. Good job. Let us move forward and onward here. Those are the correct answers there. And let's see here. I don't believe that's the answer to one. Ms. Evolva, is that the answer to one of the questions in the homework? Okay. Just double checking there. I saw the red boxes. Okay. As always, guys, don't share personal information, and lots of participation is good. And of course, you may record this for educational purposes for students who are not here. All right, we are right here, guys. We're on the third day of November, getting super close to the end of our trimester. And even more importantly, we're getting close to Thanksgiving. So that's what really makes me excited. We have 9 days left, so we're in the single digits now, guys. You can literally count this on your hands. You'd be like, this is how many days I have left in the trimester in chemistry. All right, and go ahead and get those notes open. Go ahead and click on the links, get the notes open, and raise your hand so we know that you have them open. Again, as always, that makes everything go by super smooth. And when everyone's like, I got my notes open, I got them open, then we know we can move on to call names. Okay, yes, Haley, exactly. We have 9 days left, 9 days left. Okay, so notes are gonna be 5F notes today. So while you guys are getting those notes open, raising your hands, I'm gonna go over a quick preview of what we're gonna talk about today. So we're gonna talk about pH. So pH is something, it's a way of measuring how acid or base a particular solution is. So you guys are gonna learn what that means. And we're gonna talk about what happens if you mix a super strong acid and a super strong base, or a weak acid and a weak base, etc. What happens when you mix these two things together? So that can cause some interesting reactions. So these are exact opposites. What happens when you put them together? It's like iceberg meeting fire or something. So this is our standard for the day. We're going to apply our scientific principles to evidence in order to explain how changing temperature or concentration can change how quickly a reaction occurs. Okay, so we're going to do a couple things here. So we're going to say, like I said before, we're going to find out what exactly does pH mean. What does pH mean? It's not, it's pH. So pronounce that. And we're going to figure out what are acids and what are bases. You guys did a pretty good job yesterday. We're saying what acids are and what bases are in examples, like they taste sour versus they taste bitter. So you have an idea of that as well. We're talking about what is a neutralization reaction. What is that? It's like something a superhero would do to the villain. And then we're going to learn about what is a buffer. What is a buffer? Something that doesn't allow acid or base changes to occur very quickly. Let me check the hands, guys. Let me check the hands in the open homework raised box here. So Ziggy, Morgan, Alejandro, Haley, Malik, Kevin. Okay, let's see from the rest of you guys. Let me let you know if you have your hands. No, let me know that you have your homework notes open by raising your hand, not vice versa. Okay, so we heard from Angel, Anne Marie, Ashley, Edgar, Mario, and Patrick. Welcome, Erica. Okay, let's see. Everyone's getting their hands up there, guys. Getting those notes open. Good. Okay, guys, as always, you're going to check that first box there, and we will dive into this and hand it back to Ms. Bolida.
All righty, good morning, everybody. All right, so let's go ahead and talk about what the pH scale is. All liquids are either acid, acidic, basic, or neutral. Now, to determine this, we use what we call a pH scale. Remember, you get more extreme the further from the center neutral that you are. So if the 7 is neutral, then obviously the farther left you go, farther left or farther right you go, you're going to get highly basic or highly acidic. So 0 is the most acidic thing in the world. That is dangerous. Well, look at what examples you have. Gastric juices, what's in our stomach that breaks down the food, is a pH of 2. So, you know, if 0 is the most acidic in the world, then wow, being a 2 in our gastric juices, well, that's pretty intense, right? Well, if you look at it, how many of you like tomatoes? I love tomatoes. I eat them like apples. I absolutely love tomatoes. So if you are a tomato lover like I am, then sometimes you get that red, well, when I was little, I never did, but you would get this red lip, and that would be from, you know, the acid in the tomato kind of breaking down and kind of drying out your skin around your lips. Well, because it's a pH of 4. Can you believe it? So now we're getting more slightly acidic. So less than 7 would be acidic. So anything less than 7 is acidic, whereas 7 is neutral. Human, now this is where it gets a little dicey, folks. Hopefully you haven't eaten any lunch yet, but human urine is pH of 5. So if water, tomatoes, yeah, exactly. So if water is pH of 7, then our urine is about 5. Now again, if you've ever gone to the doctor and you've had to, you know, take care of that, and what you are testing is to make sure that your urine is healthy and your body is healthy, that your kidneys are doing its job, because I'll talk to you a minute about your kidneys and about what your body does, but it filters that out, the acidity of certain things in our body. And so obviously if our urine is more acidic, then obviously our kidneys aren't doing their job. Okay. Now, if we flip on the other hand, more than 7 would be basic. So anything on the right-hand side, 8, 9, 10, 11, 12, 13, and 14 is basic. Whereas 14 is probably the most basic. So let's talk about that. And I apologize if you hear a kid screaming in the background. That would be my dear son. All right, so let's go ahead and go from slightly basic. Thank you, Ethan. Would be going from slightly basic would be pH of 7.4 would be our human blood. Interesting enough, our blood is actually slightly basic. Whereas if you use your hand soap, okay, the hand soap we use to wash our hands from everything, it is a pH of 10. Now, bleach, household bleach, we talked about this yesterday. You don't want to put your hand directly in household bleach and keep it there because it will cause chemical burns. But if you do get some bleach on your hand, just go wash it really fast and you'll be good to go. It's not going to really affect you. But if you do put your hand in household bleach, look at how basic it is. pH of 12. If our max is 14, is the very most basic, then pH of 12 is pretty highly basic, very dangerous. And so obviously the more farther you get from neutral, the more extreme and more dangerous that it will be. Okay, so let's go ahead and practice this a little bit with the graph.
Okay, there we go. So let's go ahead and enabling you guys as whiteboard tools here. So let's just say somebody asks you like, hey, what is going to be the pH of bleach? And they say it's 12. Is that acidic or is that basic? What is that? I'm picking bleach as the example here because we just finished talking about that. So remember, as you get below 7, right, it gets more and more acidic. And as you get above 7, it gets more basic. Okay, good lines there, good lines. Let's get some lines of other colors as well from other students. Let's get some red and blue and black. Let's get some more lines there, guys. So gastric juices, good. We got a gastric juice answer there. We got human urine, all right. All right, human blood, right, blue and green, nice. Okay. Yes, let's do a rainbow. Let's do the Skittles of fluids. That sounds horrific. All right. So we have some water there, right? Bleach, human urine, gastric juices, and human blood, or just blood in general. Nice. We got some red there, some post-Halloween red. All right. Good job, guys. Look at that. Like colors are going crazy there. I love that. Okay. Yes, and you guys are right. So human blood is slightly basic, and human blood has to stay exactly within a super narrow range. If your blood just gets a tiny wee little bit more acidic or a little bit more basic, it's really, really dangerous for you. So that's why your blood is maintained almost exactly the same pH all the time, no matter what you eat or what you do. You can, though, right now, sitting in your seat right now, you can actually change the pH of your blood. Not that I recommend it, but if you hyperventilate, you breathe really, really, really fast, that will actually make it tiny wee bit a little more alkaline or basic, which is why you feel kind of dizzy, because your blood vessels are constricting to your brain because the blood does not have the right pH. Yeah, please don't, but that's just, if you've done that before and you noticed that, that's what's happening. Okay, so gastric juices, yes, our stomachs are very acidic. And I think we talked about the other ones as well. And water is neutral. Yeah, no, I'm not saying you should do it. I'm just saying that if you've experienced that, or you see in movies where they're like, wait, put the little breathe out of a bag or something, because they don't want the person to pass out. So they're trying to get them to bring their breath rate down so they don't get their blood too acidic or too basic. That's why that's done. That's something you normally want to do. Okay, this is the answer to question number 2. Question number 2. Stop giving me ideas. Okay, I won't discuss that anymore. So go ahead and raise your hand once you guys have it. Give you guys 25 seconds on this one, starting now. Okay, got some hands up. Appreciate that. Alejandro, Morgan, Aiden, Chantel, and Ziggy. Once the rest of you guys get it, go put your hands up that we know you got it. Seconds. Let's make sure everybody got this. There's a lot of parts there, so make sure everyone has it. Let's see, Kevin, do you have it? Mario, Jasmine, Ileana, Haley. Okay, there we go. There we go. A couple more seconds, guys. Make sure everybody has an opportunity to get it. Edgar, Ashley, and Marie. Those hands up there, guys, once you have it. Okay. All right, let's go on to our next slide. Okay, so there are, we said before, like in the previous slide, we ranked from very acidic all the way up to 7, and then onwards to very, very basic. But things are reached by what's called the pH, which we saw that numbering system. So 1 is pretty much as acidic as you can get. We said before, you guys just saw it, 7 is considered to be neutral. And then 14 is the most basic you can get, but bleach is the example. It's almost there, right? It's like right here. It's almost there. So it's pretty basic. And you guys saw yesterday the litmus paper. You guys remember litmus paper? Remember those little papers? Or those little papers, like they dipped it into the water. We saw the little video there. Yes, exactly. So the red will cause it. Acid will cause redness. Think about it that way. So if it's already red and you put it in acid, it's going to stay red. If it's blue and you put it in acid, it's going to become red. So just think of acid red. That's the easiest way to think about it. So you can figure that out. And then blue is for a base. So again, if it's already blue, it's going to stay blue because it's not going to get bluer than blue. And if it's red, it will turn blue. If they don't change, like if you dip them in just plain, pure, cool water, it won't change color. It'll stay the color they initially were because that means it's neutral. All right. So that's kind of a simple way to tell the pH. Again, like it's like a quick test, like we do the urine test, talk about when you go into the laboratory. They're just trying to really quickly just sort whether it's acid or base. That's why they would use the pH paper there. All right, back to Ms. Boda.
All right, so we're going to watch as pH strips are used to test different solutions. Well, instead of doing that, and I apologize yet again for my children because they are home with a cold. Based on the indicator strips finely color what is the substance of the pH. I want you to think of that. Well, instead of watching a video, I'm going to do it real life. So I have here, and I'm going to go ahead and go into presenter mode. I have 3 options. Tiny, I know, aren't they just amazing? Okay, so let me go ahead and I'm going to now be really close to y'all. I have 3 things. I have some lemonade, and I know it's kind of blurry. Let me, is it blurry for everybody? Okay, let me try it again. So, let me go back. Let me try this one more time because I want to make sure that it is good, and it could be my total internet connection, so hopefully it will be better this time. Ugh. All right, well, I'm going to try it. If hopefully it kind of jumps in. Okay, so this is going to be lemonade. So I have lemonade in this one. I have laundry detergent in this one. and I have just plain water. So I have, what we have is pH strips. So again, I will kind of show you this in a little bit, but pH strips, I'm going to go ahead and pull this, and I'm going to test my lemonade. So as I test my lemonade, and again, this would be much nicer if it was a little bit clearer, but you will notice that and you know what, let me just try, just going. Maybe if I do it like this, I don't know if it will help out. So if you look at my test strip, it's kind of, and I'll tell you what the color is, it's kind of an orange color. So I'm going to go ahead and compare it to my pH strips here. And so I'm going to say it's kind of, well, it's kind of like a 3. Okay, so again, more acidic. It's kind of, and again, it could be the light. So, you know, it could be between a 3 and a 5. It's really kind of difficult, but that would be my lemonade. So that would be that one. Next, I'm going to go ahead and test my detergent. Now, this one's going to be a little bit different. And did I go ahead and just slice this one? Okay, so I'm going to go ahead and test my detergent. So I'm going to put my detergent in there. And again, unfortunately, I'm going to kind of wipe the excess off because my detergent is blue. Okay, so I'm going to go ahead and grab my pH, and I'm going to lower it here. And I'm going to try to match it. And when I look at it, it's kind of like a, it's probably like an 8 on here. Okay, it's probably like an 8 on there. And so obviously, if it's closer to like 7, it's going to be what we call slightly basic. Whereas my lemonade, which was, it looked, you know, it kind of was like between a 2 and a 4, it's going to be kind of in the middle, highly and slightly basic. So it's kind of like right in the middle there of being acidic, acidic. Now I have a cup of water right here, and this cup of water is, I'm going to literally dump it in, let it soak in a little bit. And this one's kind of a hard color to see because it's supposed to be really light. It's kind of like a light green, but it does match here with my number 7. It does match with my number 7, so water is neutral. So hopefully you guys got to see a little bit of that. I apologize that my camera was not being the best, but let's go ahead and move on. Nice job, everyone. All right, so this was, again, just kind of if we watch the video, but I did it live action, so that's what I was just doing, is kind of matching it up with my numbers on my pH level, okay? So with that, let's go ahead and complete one on our own.
Okay, so let's see here. So we got this solution right here, this solution right here. I like the colors, one of my favorite colors, actually. You're going to answer on your own, and you're going to match the colors, basically, right? That's what you're going to be doing. And you're going to say which one you think it is the closest to. And you can check your answers in the question and answer box, since this is a do on your own. And who knows, maybe someday some of you guys will work in a laboratory or in a medical facility where they're testing things like that. And this may be something kind of similar to what you do, although I'm sure they have some pretty high-tech instruments for that as well. All right, go to raise your hands once you guys have it. Let's see, Liana, yeah, I agree with you. That's what I would say too. Good answer there. If anybody else wants to check in the question and answer box, feel free. If not, go ahead and raise your hand once you got it. All right, a couple more seconds here. Random question. So if you were to put this in your mouth and pull it out, what color do you guys think it would be? Any guesses? Probably around here somewhere, right? Because saliva is just a little bit acidic, right? Not very much. So I'm not going to ask Ms. Sepulveda, of course, to do that, because I'm sure those chemicals are not meant to be ingested. Okay, let's see a couple more. Let's make sure everybody has their hands up. So Ziggy, Mario, Ziggy already answered. Okay, so let's see, Eric, Edgar. Let's see, Elena, you got it already. You asked. Okay, cool. And Marie. Okay, all right. Well, we will go ahead and go on to the next slide here.
Alrighty, so we're going to talk about a neutralization reaction. So obviously what the word says, neutralization, we're trying to neutralize this particular reaction, either a acid or a base. So hydrochloric acid is a very strong acid with a pH of 2. So it's in the realm of our gastric juices, our stomach juices, okay? Now, sodium hydroxide, which is NaOH, is a very strong base with a pH of 13. So we have two opposite ends of the pH scale, one very strong acid and one very strong base. Alone, they are both very corrosive and dangerous on their own, very corrosive and dangerous. But when you mix a strong acid and a strong base and they undergo what we call a neutralization reaction, they form sodium chloride, a neutral salt, and water, also neutral. So it's quite interesting how that happens, and we actually digest that salt, and it is safe for us to eat. We put it on our French fries. We put it on anything we want. So again, those two things by itself can be very dangerous, but when you put it together, they neutralize, making it not so dangerous, and actually and they give off water and sodium chloride, which we are able to eat and then digest. So kind of amazing what acids and bases do when they are neutralized. All right, so other neutralization reactions, obviously the neutralization, if I take a strong base and a weak acid, just like if we were in, if let's say we were boxing, okay, think of two boxers here, okay, you have a strong boxer that is really big and really strong, and then you have like a skinny little boxer. Who do you think's going to win? Who do you think's going to win, the big strong boxer or the skinny guy? Who do you think's going to win in this? It's a 50-50 chance. Yeah, but mainly people are going to put, they're going to say the big strong boxer, right? Well, yeah, in this particular case, if I put a strong base with a weak acid, I actually, my results become what we call a basic salt, which is going to be less than, or that's going to be greater than 7, and water, okay? So think about who wins. Well, it's going to be the big guy, so it's going to be a basic salt, okay? Let me go ahead and put that in there for you, okay? An interesting kind of here, if I had sodium hydroxide and acetate or acetic acid, which is just vinegar, and when they are neutralized, they become sodium acetate and water. Sodium acetate, have you ever had vinegar chips? Anybody had vinegar chips? To me, they're nasty as all get up. They're nasty. Ugh. I mean, some people really like it. And again, if you like that bitter taste, well, that's what sodium acetate is, and you can actually digest that salt, that basic salt there. All right, so let's take a look at this one, the neutralization of a strong acid with a weak base. Kind of along the same lines as they taste good at first, then then there's like some kind of, I don't eat them. My brother, on the other hand, loves them. And I always tell my brother Ryan, he's so nasty. But anyway, so in a neutralization, a strong acid with a weak base actually results in what? Who is going to be the stronger person here? If we're, again, that whole boxing match, we have a strong acid, big buff person, and then the weak base, who's the scrawny guy, who's going to win? Is going to be the acid. So we're going to have an acidic salt here, okay, which is going to be less than 7, and it's going to produce water. So again, you have to think, who's going to win, the strong or the weak? It's always going to be the strong, okay, in this result. So ammonia hydroxide and hydrochloric acid are mixed together, and what happens is you have ammonium chloride and water, which is our basic Windex, okay? All right, let's go ahead and move on this one. This just tells us that basic salt there.
All right, guys, here we go. It's about the competition here. So this is like, let's see, pretend like this is a game here, right? So they're fighting here. So we got a strong acid versus a strong base. Strong acid versus strong base. What are we gonna get? Who's gonna win? Let's see, lots of lines there, guys. You got some blue lines, you got some red lines. We need some guacamole. Let's get some green lines as well. All right, I see lots of students participating. There we go. There's the green. All right, nice. All right, can we get an orange line? Need some orange juice. I'm hungry right now. All right. So yeah, so in our epic battle between a strong acid and a strong base, the winner will be neither one, right? They'll cancel each other out, and actually it'll be a neutral salt. And I think Mr. Bova talked about you can mix sodium hydroxide and hydrochloric acid. There's both. I heard a story. There was some professor or scientist who used to do it. Take the super concentrated, he'd pour them together, mix it up, and then he would drink it, and people would be like, "Oh!" But all it was neutral. It was salt water. No longer was it like extremely acidic or extremely basic. A strong base versus a strong acid, you're going to have a basic salt. So it's going to be somewhat neutralized, but it's still going to be basic. So the base side will win there. Strong acid versus a weak base. Sadly, the strong acid will win. You'll end up with a acidic salt. Not quite as acidic as it was before, but still it's going to be like that. Yeah, chemistry are not going to be doing that today. We're not going to be mixing strong acids and strong bases and drinking it in front of you, although I'm sure that would be very entertaining. Okay, so there you go. And this is the answer to number 4. So go ahead and get that down and raise your hands. Let me clear your hands before you raise them. All right. Give you guys about 25 more seconds on this one. I think I told you guys yesterday, I had a student that did that when I was teaching in the classroom. She took concentrated hydrochloric acid and put it on her tongue because I had told her that that's what was in stomach acid and she wanted to taste it and make sure. Okay, 7 seconds, guys. Get the hands up, hands up, hands up. Or let us know that you guys have got these into your notes. All right, looks like almost everybody has them. Let's see, Anne-Marie. All right, Aiden, Jasmine, Jalen, Mario, and Patrick. All right, so you guys know battery acid? Battery acid is sulfuric acid. So if you mix it with a strong base, depending what the strong base is, it might be something that, it depends what strong base is. So if it was, for example, sodium hydroxide, you'd end up with, I guess, hydrogen sulfide or something, which is that really bad smelling chemical, but I don't think it's as poison. So yeah, just in general, I wouldn't go around, trying to neutralize it, because if you're off by a little bit and it's still acidic, or you over add the base, then you end up with a basic solution, which would be just as bad as well. So kind of dangerous. All right, let's go ahead and move on to our next one here. Okay, so there's something called, remember I mentioned before, like about your blood? Your blood has to stay in a super, super, super narrow range of acidity, of pH. It can't move even just a little bit too far. It's called acidosis. If it goes too far the other way, it can be really, really dangerous, right? So your blood, as well as other substances, has something in it called a buffer. So you have substances in your blood called a buffer. If you guys ever watch, like, TV programs about and take place in hospitals and stuff, you'll hear them throwing around names of chemicals and add this to the IV and stuff. A lot of that stuff has to do with basically buffering the blood. If the person is breathing, person is not breathing, the blood becomes more acidic. Person is hyperventilating, it becomes more basic. So they're trying to keep it in that super, super narrow range so it won't shut the blood vessels down to their brain. The idea of a buffer, it doesn't allow the pH to change very much. So a buffer is resisting a pH change. So you add a little bit of acid and not much happens. You add some base, also not much happens. It kind of absorbs the acid and base. It doesn't allow the changes to take place quite as quickly. So they bring the pH closer to 7, right? Because 7 is neutral. 7 makes us happy, not an acid or a base. And a buffer basically has, it's made up of a weak acid and a weak base. It's conjugate, opposite base. So these two weak ones, they're able to sort of kind of think about as they're reaching across and kind of like pushing back the acid from the one side and pushing back the base from the other side. They work in unison together to keep the solution relatively neutral. Okay, so this is the answer to question number 5. They resist pH changes. They resist pH changes. Also, you have buffers besides your blood after your stomach, where your stomach empties into your intestines, right? Because all that stomach acid is super corrosive. You don't want that going through your intestines. You have substances that are excreted after your stomach into your intestines to bring the blood, or I'm sorry, to bring that food, that stuff there, to bring its pH closer back to 7 again, so that your intestines are not, suffering from that. Okay, let's couple more, another 15 seconds on this, guys. Go ahead and raise your hands once you have this. Raise your hands, one and all. From Jalen, let's see, Erica, Edgar, Ashley, or you can tell us in the chat box as well. Anne Marie, okay, good. All right, 7 more seconds. Make sure you have resist for number 5. All right. Okay, there we go. Okay, so let's learn how these buffers work, right? So it's like, how do these amazing chemicals work? If you add a strong base to this buffer, right? So the buffers are like the heroes, they're like the superheroes that's trying to keep the strong base or the strong acid from dominating the solution. The buffer is weak acid. Remember, a buffer is made up of a weak acid plus a weak base. So what will happen is the weak acid will kind of reach over and will neutralize it into a weak base. So it won't let it become much more basic. On the other hand, if you add a strong acid to a buffer, then its weak base will neutralize it into a weak acid, making it only slightly more acidic. So it's kind of like, it's these two opposites, these two weak opposites, they're working together so that when one strong, either acid or base, comes in, they'll be able to reach across and not let it make much of a change. So again, this is super important for our bodies. If buffers didn't exist, it'd be hard for us to exist as well, right? We couldn't, we would be, our pHs would be all over the place. So this is extraordinarily important. Okay, back to Ms. Sepulveda.
All right, and I was thinking of another example. How many of you have made Kool-Aid before, and you accidentally put too much of that Kool-Aid stuff in there, and it was really strong? You took a drink, you're like, oh, nasty. Okay, and then as you do that, and you got it too strong, you went over to the refrigerator, you put more water in it. Well, again, it was a strong we'll say that the Kool-Aid was kind of that strong acid or base, and that water was going to be that buffer, because that water is going to make it, if once we stir it in a little more, it's going to make it a little bit better tasting. It's not going to make it so strong of Kool-Aid flavor. Okay, just another way to kind of look at it there. But just talking about our bodies, we talked about a lot about it today. Our bodies are amazing. Our bodies are, quite interesting to figure out and to kind of watch it work. It's like a great machine. And just like Mr. Corniola said, there are many buffers in the human body because your body has very specific requirements to live. We have very small margins of error because if anything is off, and just like Mr. Corniola said, if anything like our blood is off, or even our intestines, like anything like that, then obviously what's going to happen is not a good result, okay? You will not be here with us. So again, a lot of reasons why are delightful. That's why our bodies are great little machines. They are just amazing to study and watch. For example, a protein hemoglobin in your blood binds excess hydrogen atoms during exercise, because when we exercise, we are obviously giving off and we're creating lactic acid from our bodies. Well, when we create lactic acid, well, we don't want our bodies to get our blood to get too much of that lactic acid. So what happens is we have these protein hemoglobin that catch onto it and kind of almost like, all right, you're my friend and I'm going to buff you out. And so that our body and our blood kind of stay in a nice neutral state, and so that we don't go anywhere. Buffers in lungs during exercise offset changes in pH from excess CO2 and that lactic acid. Again, that whole idea, when we start breathing, just like Mr. Corniola said, you want to change your pH, don't do it. Please don't do it. We don't want anybody passed out. Is when you breathe heavily, when you start like hyperventilating. Well, when you exercise, what are we doing? If we're running, we're playing soccer, doing whatever we're doing, we're breathing heavily. Well, that changes. We have excess CO2 in our bodies and lactic acid. And so obviously there are buffers in our lungs that kind of offset so much of that. Okay. Now, kidneys. And remember, I was talking about that human urine. Kidneys keep the acid and base balance by excreting acidic or basic urine. Now, again, the reason why you go to the doctors and you have to pee in the cup, so delightful to talk about right before lunch, but because our doctors are checking for many different things. One of those things that they're checking for is to make sure that our urine is pretty at where the pH it needs to be. If it's too acidic, then our kidneys aren't working. If it's too basic, our kidneys aren't working. Again, that small margin of error there, that it's really important that the doctors find out what's going on. And obviously, that's what they do that for. So next time you go on, you could say, hey, what is the pH of my urine? And they could tell you. Hopefully it's around 5. All right, let's go ahead and move on. This is going to be the answer to number 6. So blood, lungs, and balance are going to be the answer to number 6. This is a big one, so I'm going to go ahead and give you about 30 seconds to get all 3 of those into your notes. And let's move. 30 seconds up on the clock. Here we go. All right. Raise your hands when you are finished. Yeah, how many of you, if you've ever exercised or anything, got that really bad cramp? Oh yeah, that's that lactic acid building up. That's what Mr. Corniola was saying in that in the chat box. Man, it hurts. It hurts. And that's when I go, okay, nap time. It is, Ziggy. It is. It is so painful if you're, especially a lot of runners, if they don't get the proper hydration before they do a big marathon or big run, and they cramp up. It's like it is painful. That's why a lot of times, people who are playing a really kind of intense sport, they'll either drink a lot of fluids, really hydrate themselves. My husband, I remember in high school, he used to drink Pedialyte before his football game because he didn't want the lactic acid building up. Again, kind of making sure that you hydrate yourself. Yep. Carry me home. I love it. All right, let's go ahead. Anne Marie, Ashley, Edgar, Jasmine, and Mario. Let's get our hands up. Ashley, Anne Marie, Edgar, Jasmine, and Mario. Get your hands up or let me know in the chat box. Or you could just do yoga. Yep. The best thing is to kind of stretch it out. And again, it's so painful you don't even want to move. You just want to crawl up into a little ball. Yep. All right, let's go ahead and move on. Nice job, everybody.
Right. So you guys have probably heard of antacids before, antacids. And basically, these are things that, as you can kind of imagine, anti is against acid. They basically will release these hydroxide, these OH ions, right, into a solution, which will combine with the H's to make H2O, neutral water. So they're able to sort of counteract the extra hydrogen, the extra acidicness of usually your stomach, or if you're getting, we talked about yesterday a little bit, you get like acid reflux or something. Some people have that tendency. I think I mentioned recently, I just started noticing that with myself as well. I'm like, oh, what happened here? Some of it's what we're eating. Can be if you're eating late, different things like that. You can start having more of an issue with it. But basically, it will basically just literally counteract the acidity of our stomachs. So they'll include buffers as well, because you don't want to go too far the other way, right? You don't want to make your stomach then suddenly too basic, because then you have a totally different problem. So they help you kind of keep your stomach acid down a little bit, but not too much. So this is going to be the answer to question number 7. So go ahead and get your hands up once you guys get this. Morgan, you're fast on that. So go ahead and get your hands up once you have this in your answers. Let me set my timer here for 25 seconds. Antacid. That's A-N-T, not A-U-N-T. Okay, another 10 seconds on this one. All right, let's hear from everybody. Let's see, we missing anybody? All right, a lot of hands up. Let's hear from everybody else. Angel, Anne Marie, Ashley. Let's see, you guys are doing it as quickly as I'm saying your names here. Patrick, Mario, Jasmine. Let us know if you guys need a little bit more time. Okay. Oh, there you guys go. Okay, cool. Okay, that's pretty much everybody. Let us know if we need more time, guys. All right, so there it is, guys. So you guys now know what pH is. It's a measure of how acid or base it is, right? Remember, 1 is super acid, 14 is super base, and then 7 is in the middle. We talked about neutralization, right? So if you have too much H, you add some OH and you get plain water, and vice versa. We talked about buffers and how they're super, super, super important to our body to keep our pHs in the various parts of our body exactly how it should be. All right, guys, go ahead and let me enable your whiteboard tools. Go ahead and give us some feedback. Give us some feedback. You can do the B's, or you can even draw a little star if you want to, but let us know how you guys are feeling. Let us know how you guys are feeling about this topic. Are you very confused? Are you feeling still needing some help? Pretty good, or are you guys awesome? There we go. We got some more. Okay, cool, cool. All right. Like the feedback, guys. Appreciate the feedback. That helps. Okay, in a few seconds, in case anybody else wants to kind of tell us what you're doing. All right. Good, guys. Good. Appreciate it. Okay, so that is it for the day. That's a wrap, as they say. If you guys need me to go back, if you missed one of the questions, I'm happy to do that right now. Other than that, the rest of you guys can submit your notes, and I'll see you guys, or we'll see you guys on Friday.